Hopefully I'm a good cover band for Chris. All right, this talk is really about how to do data residency without making yourself and others miserable. So the big thing, right, like the motivating example is we want to put our data somewhere other than just one place. And you could do that a lot of ways. You could do that for a lot of reasons. You could do disaster recovery, you could have geo-redundancy. Today we're really talking about, I want some of my data to be somewhere else and have not any of it shared between those two regions. So truly the data lives somewhere else. That's what we mean by residency. So hopefully that's the talk you're all here for. Cool. Roadmap. So who am I? What are the first principles we're going to be talking about? And then we'll actually go through some architecture diagrams towards the end. Cool. I work at Rippling. I'm a staff software engineer on the performance and architecture team. I've been working specifically on making Rippling a multi-region data residency enabled platform. So we've been a global HR and IT and finance company for a while now. And we are enabling EU, UK, and Canadian data residency in the coming years. So we've been actively producing this exact work that we're doing today. A picture to be a nice palette cleanser from all the logos. This is me. This is my dog. I'm a real person. Cool. OK, so right into it. The first thing that you really need to know is who are you doing this for and why? You really need to know who your customer is. So it turns out that this is not a GDPR requirement. If anyone tells you, the first thing anyone says, you come up and you say, oh, we're doing data residency, we're doing data sovereignty. And everyone goes, oh, the GDPR thing. OK, cool. You actually don't have to do this for GDPR. So if that's the reason, go find out who actually wanted this, because it's not a direct GDPR requirement. You can, and many very large companies, top of the industry, do this without doing European data sovereignty. So cool. Why are we doing this? It turns out that actually this is a thing that your customers want. So someone wants to buy this from you. Typically, this person is a company in the EU who is concerned about data privacy, is concerned about regulatory exposure to the US. A number of perfectly legitimate reasons that someone living in the EU doesn't want their data to go through the US where it could be exposed to US jurisdictional concerns. You need to find out, you as the architect of this, need to go find out who actually wanted this thing. Why did they want it? You need to go talk to sales, you need to go talk to your customers, you need to go talk to legal, because the requirements for this project are actually going to be, what do you want to be able to say in the contract? What is it that you want to promise people about their data residency? So it's not, step one is figure out what exactly are the requirements. At Rippling, our biggest thing was we have customers in Germany who had specifically asked for this. We want to enable this for European customers to feel safe about having their data in Europe. Cool. That means a whole set of restrictions around what we can actually do. We don't have our regions able to talk to each other. Other people can because they have different requirements. So it's really, really important, and I can't stress this enough, 2/3 of the first phase of this project is just going to be you sitting in meetings with legal, understanding exactly what it is, who it is wants this thing. Cool. Other reasons that you might want to do this, cell-based architectures are great. And it sounds like Chris, right after this, will be talking about how to do it. So you can help scale your system. There's a ton of reasons to say that I have a lot of European customers, I would love to have their data near them. You can do that without doing fully separated, fully isolated data residency. So that wouldn't be a great use of it, but having your data separated and partitioned like this actually can be really good from a scaling standpoint, because you have independent databases and independent architecture. Cool, great, distribute things. I just told you this wasn't for GDPR, but this can be part of your compliance story. You may have jobs, audit jobs, all sorts of stuff that runs that's part of government A's package of compliance. The UK has a bunch of labor laws that are interesting and different than the US. we have to comply with them, but we don't necessarily need the UK jobs running against the US data. If you have everything in one big place, you have these jobs, and there is the potential, however hard you work against it, that the job could access the wrong data. It happens all the time when things are in the same place and share credentials. Great. You may find that some governments don't get along that well with each other, and that their rules are mutually incompatible, or that their compliance jobs are odious to other governments. Those would be great reasons, if you have to implement jobs like that, to have it in a different region so that the data against which your compliance jobs are run is specific to the government to which it applies. Great, so that's kind of why. So, to wrap that up, know who you're doing this for, know why you're doing it. Don't just say, oh, we have to do it for GDPR. Oh, we have to do XYZ thing. It is really going to depend on you, your company, and what you are trying to do. Cool. The next big principle that we were going to talk about today is truth and trust. So, in a multi-region deployment, you need to have a firm answer on what the source of truth is for a particular piece of data. That is generally true. Like, that's not just a multi-region concept. That's a good thing. You should probably know where your data is supposed to be. However, in multi-region, I think it's very important to separate that which can be divided from that which cannot. So you should pick something that your business treats as an atom, a container in which every single thing lives within one region. At Rippling, that is called a company. At your company, that might be something else. It could be a team, because your teams are in different regions. It could be an org, and we say that all of the sub-companies and subsidiaries all live in the same region. Again, that's going to be up to you. I highly encourage you to define an atom. And so when you say inside of the atom, everything that is part of this will be in one region. When you make a cross-atom call, necessarily you are talking about a cross-region scenario. It is not hypothetical that you will have something in a different region. You may get lucky and they're in the same region, but any cross-atom call is necessarily now a cross-region call. Cool. So pick your source of truth. Trust. So you have different regions. They have different data. And you're going to find yourself having to have them talk to each other. Now, there's a lot of reasons they need to talk to each other. Things like auth tokens. My user signed in the EU and is actually part of a US company. They need the ability to log into their US instance and get the US data. Does that mean that the US needs to trust the EU-issued auth token? Maybe. Maybe not. You're going to have to decide from first principles, because this is not something you can do after the fact. You have to decide what is the level of trust that you can accommodate in your business between these two regions. For starters, if your only regions are going to be, say, US and EU, that's actually a relatively high degree of trust. If you have governments involved in your cell architecture, and you're going to put a cell in a government that is hostile to another government, you are going to have to think about how much those cells can trust and talk to each other. And so this comes up all the time with oh, we're going to do, we have a US data center, and we're going to add a mainland China data center. So it is very important to think about this before you do it the first time, because if you have good answers to all of this, and you have a good philosophy and architecture grounding your design before you've built it, when they say, oh, we're going to use XYZ country, it's our next big market, you're ready. If you're grappling with that later, you're going to find yourself having to revisit a lot of your fundamental design patterns that you did the first time. So you're going to have to do a threat model. You're straight up, you're just going to have to sit down with your security team, maybe security consultants. You're going to want to understand, what is it exactly that we are protecting ourselves from? What exactly are the regulatory requirements in the various countries? What can we trust? So, double click. So the big ones are access tokens are going to be, for sure, something you're going to have to think about. The other one is database access. Now, you may have a dozen other things you have to think about, but those two are absolutely concrete. Every single application that does this is going to have to answer those two questions. You know, and there's like all cute cryptography you can do to enable the trust. You can make a direct call once you get in. You know, there's all sorts of stuff. If you go stateless, is it okay that the window of trust extends from when you authored the token? You know, revocation delays might not be acceptable with replication. It's going to depend entirely on what you're trying to do. So anyway, at least those two you will have to think about. And usually those two conversations, when you have them with your team, will lead to a bunch of other conversations around the other things that are relevant to your business. So start with those two. The last core principle of multi-region, and like a lot of software engineering, so this is not particularly multi-region specific. However, the problem here is exacerbated by multi-region. We'll go through this, but do the same thing every time. If you have an option where you have a fork in the road and you could just not have that fork in the road, that's a better design. So we'll go through a couple examples of what I mean, and then we'll apply it to multi-region. So this is a example from network routing that is from back in the day. My mentor, Tim Worsley, told me this back when I worked at Minted. You say, I have a router, I'm designing a router, and I'm designing a routing path. I want it to be as fast as possible most of the time. And then if there's a lot of load, I have this queue, and I can just queue up requests. So on the face of it, that actually sounds like a relatively reasonable design. You're like, OK, most of the time it'll be pretty fast, and that's cool. Everyone likes low latency connections. And then I have some like strategy of dealing around overflow, spikes. I have a way of dealing with this. Let's diagram this situation. OK, so we've got our router. You know, we have 100 units of computing, whatever it is. And routing the request takes 1 unit. And adding to the queue takes 1 unit. Cool. Problem. If you get a single traffic spike, you may be knocked off the internet forever. So how did we start with such a seemingly simple, straightforward design and end up with like a pretty bad failure case? If you're running at more than 50% capacity, if we go back to the diagram, right? You know, 1 cycle, so could do up to 100 requests a second in regular routing mode. It takes a cycle to add to the queue. That would be 2 cycles per request for queued requests. So if I have 51 requests a second, and I go into queue mode, that's 102 compute cycles to do my original baseline 51 requests a second load. Not only does my queue grow to infinity, I also have the spike to add on, because I will never dequeue those. So I'm just like permanently delayed. This is never going to recover. There we go. So, you know, obviously we don't have situations where we just have like queues growing to infinity very often, right? Like you're like, add more workers, cool. I bet a lot of your systems, when you go in Datadog or something, look like that right-hand chart. So we've modeled a router, and you know, there's just some, 10 requests a second, or baseline load, 25 requests a second limit. There's some degradation when it goes into queue mode. And so, you know, at the period from 40 to 43 seconds, I gave it just 20 extra requests. So, you know, in theory, I had capacity to handle that in 1.5 seconds. And what I actually get, you know, this is, if you're curious, I can show you, it's in the appendix, but I get this big latency spike where my latency goes up to 3.5 seconds over like an 11, 12 second window. So by just this like less than 1 extra second of capacity in this real system, I get this huge latency spike on the right. And so this actually happens a lot if you look at like, you have a garbage collection pause or stuff like that. Now, OK, how does that apply to multi-region? You're going to be doing a lot of routing, right? Not network routing, but like person comes into your system and needs to get to the right data center. Now, you have a choice. You can either, oh, well, I'm going to say they're going to be at the nearest data center most of the time because the EU customer data is in the EU, duh. And then only if they're in the other region will I incur this extra cost of routing them. Try to avoid designs like that. Stick with designs where you do the same thing every time and you say, I'm going to come in, I'm going to figure out where you go, and I'm going to route you. OK. We'll cover more concrete on that in a minute. The other thing to do is maximize the likelihood of it working by reducing code branches. Now, I put the clown emoji here because this is meant as a joke. As your feature set grows to infinity, the percentage of those that work converges to 0. Now, OK, no one has infinite features. But you do have a limit to how much you can QA and test a specific code path, right? Like, as you add complexity, as you add new features, stuff that wasn't tested or wasn't covered in tests or people aren't using kind of tends to break at a constant rate. And so that's work to fix buttons that people haven't clicked on. And so if you have a part of the app that people don't go to regularly or your QA has been neglecting, what you'll find is that things sort of fall off the working path. The actual thing is, probability of something works is directly proportional to the fraction of users that use it divided by the complexity of the feature. Now, it's not really good math if you tried to do a probability distribution as a percentage. Like, it's not going to work. This is conceptual. But if you have a situation where you have a split between your low user percentage scenario. So our scenario where we have most of the people are going to route to the local region. That most of means that the people who aren't routing to the local region are a small minority, low percentage of users. Routing between regions is a high complexity item. So the probability that works is actually quite poor. So really try to reduce the number of branches. Try to reduce the number of forks in the road that you can do with. Do the same thing every time. OK, so things specifically to be cautious of. The geographic nearest region, the one we just covered, the problem with that is you have this very rarely used code path where you fork in the road and you go to another region in exceptional circumstances. That's actually really hard to test, right? Because to have your QA do that, they need to set up an account for the other region, get in the, so first off, you have to have region architecture stuff for them to test on. So these brittle, rarely used code paths, it could be broken, and the 6 customers it impacts, you'll find out in a week that their experience is degraded, and now you've got to go debug it. It's brittle, it's rarely used, try to avoid that. Another really similar example would be, most of our writes are actually going to US1, right? Like most of our customers are there, we're going to, we have this shared table that we're going to replicate out from the US data center. The problem with that is your application is able to make the expectation of synchronous consistency in the US. So you wrote to the database and you read and you got the same answer. When the EU path tries to do that same code, it writes to the database and it reads, and it will not have synchronous semantics. It will be asynchronous. Try to avoid situations where you have that difference, because those bugs are going to be hard to track down, because your test ran probably in an environment similar to the US one where you had synchronous consistency, and just even stuff like write latency, when you have to go cross-region to write, is going to vary between the regions. And so you may not have a performance issue with a job that the first time you try to run it in the EU, it's going to make this huge network hop, 150 milliseconds to, generously US1 in Virginia or something. It's used to having 1 millisecond latency to the database. It's 150 times slower all of a sudden. That's probably going to break the first time you run it. So an application of this principle as a diagram. So the left-hand diagram is exactly what we said. Like, we're going to have the app write to the database in region 1, and region 2, we're just going to have region 2 change out its write path to write to the US database. We'll replicate it back. Region 1 here has a synchronous read path to its local database. Region 2 doesn't. So this would be an example of something that would create subtle bugs and should probably be avoided. The right-hand diagram, however, doesn't have this because we have perfect symmetry between the 2 regions. When possible, try to maintain this symmetry. That's a nice design because you maybe have a little more complexity. You have to stand up this global region of data. But both region 1 and region 2, and presumably your test architecture, which you'll implement some version of write database and replica, all have the same code path. So if it works in one, it works everywhere. Great. So now the probability of it working, if we go back, is proportional to the percentage of users divided by the complexity. Well, the complexity term doesn't really come into play if you're at 100% of the users. So your app is just broken if the path doesn't work. And that you'll know about a lot faster than if you broke a niche edge case. Great. Let's talk through what we actually do to do this. So your application is an onion. You have, you have your edge, you have your app servers, you have your database. We're going to put circles around it somewhere. This is, to everything outside of this layer, the inside contents of the circle present as one item. So client routing. The easiest one is you just give everyone subdomains, eu1.yourapp.com, us1.yourapp.com, and you have the client now. This was the first generation solutions of doing cell-based architecture, the real pioneers in the field. This was all that was available. And this works great, but it is a little bit annoying to your customers because they have to implement all of the routing logic themselves. They have to know. And for most of your customers, as long as everything their domain of concern is within the atom that you decided on, in the source of truth, they're going to have a fine time because they just keep interacting with the same region and everything works the way they think. It's going to get hard if you move someone's region, though. Your customer submits a ticket saying, I'm in region 1, I want to be in region 2. All of their integration is going to break because all of their webhook URLs, all the stuff they stuck in their code somewhere, every time they make an implicit assumption on the URL based on the client domain knowledge of your routing, all that's going to break. So you will find use cases where this is important and is something that you have to do. However, maybe don't consider it as your first choice strategy. Gateway routing. So the next thing is we have atoms, right? We talked about a source of truth and an indivisible part of our application. What if you put the atom ID in the request and you have a map at the edge that just knows where the things are? That actually works pretty well for most use cases. So for traffic that lives within the atom boundary, that actually is a really good way to route you. You just include, in our case, the company ID. You include the company ID in the request as a header, as a query param, doesn't matter. Path param, fine, anything. The atom ID is now your routing key, and you just know what region. If you change regions, you just update the mapping in the edge, and the traffic will go to the correct region. Great. This doesn't work so good if you have cross-atom traffic. So, you have a partner that needs to access 2 companies, and they do different things, and they're in different regions. Well, you can't actually route with this all the way. So you can get to the partner's first region and then fan out and do stuff, but you're going to need to do something other than just gateway routing in that case. So what do we do now? OK. You could have your regions be able to talk to each other. That's actually a pretty good idea. When you have these regions, they are able to make calls. So again, you're going to come into the idea of trust between the regions. However, if you can have a situation where access cross-region is allowed by your security policy, by whatever it is you're trying to do, and it's OK to have cross-region data access, which again, often is the case because this is not a GDPR compliance matter. Data access for a legitimate business purpose is often permissible. Not always. Check first. But you will find that something like having your application be able to talk across a region is going to be useful. Now, this is another great example of I have a query that needs to access 10 companies that I know about. If you have your atoms in some sort of routing key, that's a great way where you can build a batch API, and you have a list of company IDs that this applies to, and the framework can automatically route to the appropriate regions. So again, use your atoms when you're able to. Sometimes you just won't be able to. You need to run an audit job on everything in every region. You could do that too. You just set up a service that doesn't work around the atoms, and then the regions can crosstalk. The problem with this is it's very complicated, and you get a lot of regional latency when you do actually have to make these requests. So, you got to remember the New York to Shanghai latency, which is about the worst it gets, is like 400 milliseconds. Most good APIs are already returning before that round trip has been made. So that can be a killer. You need to carefully consider how many of these you're doing, and you'll need to structure your app in such a way that it gathers the data requirements up front and they flow through the request rather than, oh crap, I was missing this piece of data. Oh crap, I was missing this, and just iterating through and making a ton of these calls. Let's see, database managed locality. So there's a lot of databases out there that will say, oh, we're a global database. And they often are. They're actually really cool. They do stuff like replication. They do stuff like select, you can give a region key and it'll store the data in that region. We do have to talk through that a little bit because you have to think through what kind of use case they were trying to enable to decide whether this magic database is going to work for you. So there's accelerators. This is typically an active-passive topology where, think like a CDN. You write once, all the regions get an eventually consistent copy of it from which they can pull to accelerate the data flow in the local region. Great. Global databases, these are true global databases where they have some sort of genuine active-active topology cross-region where you can write from anywhere, you can read from anywhere, and they guarantee eventual consistency on it. Okay, accelerator's not really that applicable for data residency because inherently in it is copying the data, which was the whole point of the project. However, they're really good at some stuff. So like my example of this is like the US tax code is the same everywhere. Everyone who has dealings with US business follows the same tax code. That data is a perfect example of something to replicate cross-region using one of these eventually consistent accelerator type patterns where you write and it replicates everywhere and everyone has a nice local copy of this. Why is that a great example? The data is consistent, it's not related to a specific company, and it doesn't change very often. So that'd be great data to use this for. So this can be a part of your solution, but obviously it doesn't speak directly to the residency aspect of the solution. True global databases, you do run into a problem where you either have an active-active topology where last write wins. That can cause some issues, obviously, depending on your use case. If you have regions that may act on the same object at the same time, one region can say, oh, I committed this. The second region says, oh, I committed this. But only the data from one of those two commits is going to survive the reconciliation. So if that's a write pattern that's applicable to your use case, that could be great. This could actually be a huge win for you. That's not often the case, right? Like if you have a conflict on a write, you probably need to resolve it some other way than just having last write win for a lot of systems. Obviously, if you do this synchronously, you have to have a quorum between all the nodes. That's going to cost you the cross-region latency to achieve. So that's going to be really slow. And the spec sheet, you don't typically see something about partial replication where you can say, oh, I want this set of data replicated and not this other set. A few vendors can absolutely do that. You're going to have to carefully read your spec sheet, understand what technology is going to work for you and not, and then thoughtfully think of this. Unfortunately, oh, we're just going to stick a database proxy in front is not typically a one-size-fits-all solution for enabling data residency, as convenient as it sounds like it should be. Cool. So pulling it all together, you are going to have to ask your team who it is you're building this for, what exactly the requirements are. So it may surprise you, the answers, and this is an incredibly important part of the exercise. When you're working through the trust and truth, it's important to define an indivisible part of your architecture and then an encapsulating idea. So things above can be cross-region, and things below never are cross-region. That will help immensely in keeping yourself sane when developing code. Do the same thing every time. When you see forks in the road, especially related to region resolution, related to business logic in that domain, I would strongly encourage you to think of ways to try to work around those forks in the road so that the code path followed is consistent. Again, when you're testing, when you're building your test and rollout plan, when you're making changes in the future, it's going to be hard to know that you've broken one of these delicate mechanisms that's on a rare code path. Try to get rid of those. Cool. At this time, I'd like to move it to questions from you guys about like, how would I model something? How would I go through and really understand a scenario in your business, or any questions about this topic?
Got a strong slant for data residency from a regulatory reason or some other business reasons. But what if you're just interested in having data reside close to users for faster round trips, and you don't want or don't trust database replication?
Yeah, absolutely. So some of these, first off, the big differentiator between those use cases is it okay for my data to reside elsewhere also? Maybe data replication isn't the technology that you're going to choose to do it with, but the differentiator between a sort of like my users want a fast experience and I want to do data sovereignty and data residency, that makes data residency harder is the lack of ability to replicate the data. So absolutely, you can use a lot of these techniques. Particularly the database accelerators are great. You can run audit jobs. If you're in a world where eventual consistency is okay, that's an awesome way to go about it. A lot of the disaster recovery scenarios and whatnot. The thing that makes it tricky to say like there's a huge win for if you don't trust database replication is that all of the other layers at which you can do this are like pretty difficult to combine effectively. So if you're in a situation where the atom of truth for you is very well aligned with your business and not a lot of things are going to make any kind of cross-atom call, or even you could say nothing is allowed to make a cross-atom call, then you can use some of these designs like the gateway routing would be a great way to do that if that's applicable to your business.
Well, I still got the mic, so I guess I'll ask my second one now. If you go back to your trust slide.
Yeah, absolutely.
Trust is the first principle. Totally agree with that. I got a little bit lost with the example of do I trust the authentication token from another locality? Is that not just a policy decision at runtime?
It can be.
What am I missing there?
So the question is like, we have this problem well, it's not a problem, but we have at Rippling, you can be employed by multiple companies. So, you in the context of your first login is with a company, and then you may switch to go see a W-2 from another company. You're a contractor for two companies. There's a ton of different scenarios where you could legitimately interact with multiple regions. And so the question is you logged in, we gave you a token at first. You bounced to the EU. We decided that first token for us is not good enough. You're actually going to have to go through a token exchange and get a token specifically. And
People work remotely, and more corporate assets
what we said was that we did not trust in general the tokens, but we actually the policy that we use is if you're going to access a role, you're going to access your employment with the company, you need a company-specific token as a general user. So for stuff where our partners are talking across companies, that's kind of a different use case. We have a different set of challenges there. But for regular users, what we actually said was you need an atomic token, which, multi-region or not, you're going to need to log into that specific company. So for us, we don't trust the token at all, and we don't even trust the token within the context of a multi-company call. You just get a specific company, which is an atom, and a specific atomic token for that region. So that was kind of our solution to this. Hopefully that gives some context.
Sure.
All right, there's no other questions. Please
Ooh,
be sure to.
We got one here.
All right. See who beats up.
If you do want to ask a question, please raise your hand high. The lights are like really bright in my face, so I can't actually see y'all very well.
I actually have a very sort of maybe very specific scenario. Like
Yeah, absolutely, please.
the thing is, usually when you write a client to get anything, right, you need to have expectation of time. So if you are making colloquially, the time bond is pretty tight. If you
Right.
make a cross region, it's much higher.
Right,
And
right.
also, it's dependent on how far the other region is. and
Correct.
That varies a lot. So my question is, like, are there any kinds of rules of thumb saying, if the region is this close, and then you can sort of paper over that difference, say, I would just set a generous bond and treat every region more or less the same. Or there's a point where you say, I will have per region expectation. So it essentially fork the configuration depending on the destination. Like, is any of the design patterns you talk about better or worse?
Yeah, absolutely. So one of the things so first off, we would be, by doing that fork configuration, we'd be in violation of do the same thing every time. It's a great principle, you might not always be able to apply it. The design I would suggest that probably is most applicable to this is your application layer routing. Let the client, you probably don't want to leak this detail of cross-regionality or latency to your clients. They really would prefer not to care. They're going to make a request. Who they're making it to and what atom they're trying to interact with is going to be a detail of what they have to do. They don't get to choose, they don't really get to control it, and it's going to take as long as it takes given the scenario at play. What I would say is that obviously your client's going to have expectations. Typically, those expectations are derived by their typical use case. So like your developer is going to start working with this API and get some pattern and latency. Part of setting those expectations is to have your thing work the way it's going to work in prod for them while they're developing it. So if they're always interacting with their own company and it's always 400 milliseconds because it's very far away for God knows what reason, at least it's consistent. I think to some extent there's no true answer to that question of like, how do you stitch this all together so that truly the client does not have to care at all and can have the same expectation no matter what region they hit. The obvious answer is like if you do hit New York to Shanghai and it's 400 milliseconds, like unless you're going to add a sleek 390 in every other region, you're going to have a different experience. The thing I would do, so in the fan out step, right? So you have this kind of scatter gather pattern within the application routing framework. So you've got all the remote regions, and you might say, I need to run this on every remote region. If you can scope that, so if you do atomic routing on your scatter gathers, so you say, I'm going to access these companies, the odds that you hit a very far region, like the South Africa region, go down unless there's a legitimate use case to do it. So again, it's all about when you can use your design pattern. Because again, if the client has a legitimate use case for accessing highly remote data, it will take longer, and then it's just an expectation management problem. So to the extent that you can try to keep things consistent, it's going to be, especially for your first time or early deployments of multi-region, would highly advise that. Look, you can do this, and then as your company grows and you find you have these niche use cases, like you can add routing infrastructure later that will help deal with some of these specific use cases. Probably for the beginning, I would start simple.
I
Hey.
Question. What happens when you start the process, you define your atom sizes and what you want to be data resident, and that actually changes over time. You have a next customer who wants more things to be data resident, but you didn't make that decision in the beginning.
Mhm.
How do you deal with the transition, deciding, well, do you move the line, or how do you adjust the customer expectations? And kind of a follow-on question is, more practically, how important is it to build the ability to move customers between regions as a kind of a first feature you might want to build?
So I'll take the second one first, which is how important is it to move customers? So I can tell you exactly what our reasoning is. It's quite simple. If you're a Rippling customer today, obviously it wasn't a blocker to you buying Rippling. If you're not a Rippling customer, it may be a blocker. And we have enough people who are not Rippling customers who are telling us they want this. You could say, as a business, you could go out and say, well, great, if it wasn't a blocker, clearly you've already bought us, we don't care. We're going to build it only for new customers. That'll probably get you until the first renewal cycle when the customers that it was a tough sell to say, oh, we're going to do it right in the US. And they're like, you have data residency now. Move us. It's going to be a tough sell at that renewal to say, we've built this thing that does exactly what you wanted always in your dreams, but you can't have it. So the answer is, I would say, it is not a launch blocker to multi-region. However, you should expect to need to do it probably within the first year or so, or at least have a good timeline or answer on when are you going to enable it. Could you remind me the first part of the question?
The first question was really if you got your dividing line wrong.
Yes,
where you,
absolutely.
Customer, you say, okay, I'll put this set of your data in this particular residency thing. And the next customer says, well, I also want X, Y, and Z to be in the region too.
Yeah, so the balancing act here is between the complexity of breaking up those atoms and not. So like, if you draw the line higher and you say more of these things are going to be data resident at the beginning, you have more problems because you've made more complexity for your initial launch. I would say that that complexity pales in comparison to moving the line afterwards. Set the line relatively high up as you can. Say everything that is customer data, like ask your legal team what it means to have customer data. So another example at Rippling is like, okay, you're a person and you have some personal data, but you're employed by the company and they own the data about your employment. Where do you draw that line? Like, what is personal data, what is company data? And for us, the answer is actually much more of it is company data than you would think. Maybe if you came in this naively, if you understand the HR and compliance space, actually probably wouldn't be a surprise to you where we drew the line. But it's something where it's like, if you draw the line too big, you're making a small amount of pain up front. If you draw the line too small, you're making a great amount of pain later. So I would err on the side of saying something like all company data has to be within the same atom. Now you could go larger than the company. You could say the whole org, like a collection of companies, actually lives co-located in one region. That may or may not work for your business. So that's kind of different things you're trying to balance in terms of where you draw that line.
Hi, thank you again for your talk. That was quite insightful. So I come from the telecom space, and our main KPI is basically to drive down the cost to serve. And we're basically driven by ensuring that our customers have on-demand hosting fees, long story short. And so we operate a lot of ephemeral instances that have to do a lot of doing ourselves for overflow. Do you have any tips in dealing with, let's say, dynamic regions or atoms are spun up dynamically in response to load? So in this case, the region doesn't always exist. Sometimes it exists for maybe 30 minutes and then it goes back down.
Yeah, to the extent that you can follow the gateway routing pattern, you're going to have a much better time with ephemeral atoms because, yeah, it pops into existence. As long as you update the global data store that is powering like this mapping of thing to region, you're going to be fine with ephemeral regions.
Okay.
If you can't do this, it gets ugly. If you have this scenario, you're going to have to update the map and dynamically in the application router, and that's going to get kind of hairy. And then if you're in the database replication scenario where like you're now like replicating databases dynamically to different regions, that I don't know of anyone who does that. There might be someone.
Okay, thank you.
Cool. Yeah.
No questions.
Anyone else? Going once, going twice, sold. Let me put up our little vote panel. Thank you everyone for coming to the talk today. Hope you guys gained some insight in multi-region and what to do. Even if you're not doing multi-region today, it's food for thought. You can start aligning your architectures with kind of what's needed for this now as pre-work. And just having a knowledge of what this sort of challenge is going to look like for you and your business can help you decide, even if it's worth having this conversation with your leadership team about, does this even make sense? So again, thank you everyone for coming, and I'll stick around for a few minutes afterwards if you guys want to talk.